This is preview video 3.4, coordinate proofs. Sit tall, ready, inhale. Deep breath, hold. Slowly exhale. Take a look here, folks. 3.4, we're going to be dealing with coordinate proofs as they relate to triangles. Don't forget date, time, and location for your sign-offs. Before we do that, let's recap our centroid here. In the diagram below, points A and B are midpoints, which makes R to B and S to A medians, which makes H a centroid. You are told that R to H is 6x. R to B is 8x plus 3. Find everything possible. All right, let's see how you did, folks. So first we're going to start with our thing equation. Our thing equation is this. We know that R to B, that's the green, equals R to H, which is the blue, plus H to B, which is the red. That's pretty common sense. Red plus blue equals green. What you need to remember from the previous lesson is, if that's a centroid, this is a 1 bunny hop, 2 bunny hop measurement. So now we circle, plug, chug. R to B, we are told, is 8x plus 3. R to H is 6x. We are not given anything for H to B, but H to B is half of 6x. Therefore, it is 3x. Solve. Now, once you plug that in, let's see if it actually works. 6 times 3 would make this 18. 8 times 3 is 24 plus 3, which make this entire thing 27. And then half of 18 is 9. 9 plus 18 is 27. You're good to go. Math has meaning. Say that with me. Math has meaning. Math has meaning. Numbers are simply an expression of our physical world. They don't exist just to give you headaches. Math has meaning. So we're going to talk about some math and the meaning of the math physically. So for example, if you wanted to show that segments were either parallel or perpendicular, which one of these 3 equations would you use on a coordinate plane? I'll give you 5 seconds to circle. Parallel and perpendicular are both tilt issues. So what shows tilt would be slope. Slope gives the meaning of tilt. If you wanted to show a segment has been bisected, which one of these three equations would you use? Distance, midpoint, or slope? 5 seconds. Bisected means to go through the middle of something. Therefore, to show the meaning of bisected, you would use the midpoint equation. If I wanted to show two segment lengths were congruent, which would you use? Distance, midpoint, or slope? Since the key word here is lengths, you would use distance. I'm going to check to see your understanding. Okay, so I'll give you one example, then you're going to do two. It says right here, if you wanted to show on a coordinate plane that opposite sides of a rectangle were congruent in length. If I wanted to prove mathematically that this length was the same as that length, this length was the same as this length, would I use the distance formula, the midpoint formula, or the slope formula? If I wanted to show lengths were congruent, I would use the distance formula. You read this page and fill in the blanks and circle the corresponding equation on your own and then restart the video, please. Please don't just copy. Try it on your own and then restart. Pause and restart. Welcome back. Hopefully you actually followed my directions and you tried this first on your own. Says right here, if I wanted to show on a coordinate plane that consecutive sides of a rectangle, that means sides right next to each other, consecutive sides were perpendicular or meet at right angles, what would you use to prove that there's a right angle there? You would use slope. And the reason is, if I found the slope here, I found the slope here, and we know slope times slope equals -1 for perpendicular lines, that would prove there's a right angle there. Down here, if I wanted to show that the diagonals of a rectangle bisect each other, in other words, they go through the midpoint of each other, I would do the midpoint equation. I'd find the midpoint of the red, I find the midpoint of the green, and we would prove that it is the midpoint going both ways. The midpoint equation has the meaning of middle. I'm going to introduce to you something called a midsegment. A midsegment. We're going to use the coordinate plane and working with a midsegment. In triangle PQR, mark D as the midpoint of PQ. So D is the midpoint of PQ. So eyeball it. D is the midpoint of PQ. E is the midpoint of QR. So here's QR, E. Draw and label. We're going to trace the segment D to E. Draw it in. Now, I'd like you to just first trace DE and PR. Just trace it. Trace. Do it a few times. There's an observation there. Just by tracing like this, you should notice something about these two segments. That's the first thing I'd like you to write. What do you notice just by tracing your fingers like this? I'm not going to fill that in for you. You should feel it. I want your own brain to go, aha, trace. Number 2, I'd like you to finger pinch. If you've done this relatively accurately, you should be able to see this. Finger pinch, DE. Now compare it to PR. Watch my fingers. Finger pinch, DE. Hold that distance and compare it to PR. Finger pinch, DE, compare it to PR, excuse me. You should notice something there too. Whatever that is by the finger pinching, I like you to write it down. So this one we did by tracing those segments. This one we did by finger pinch. There were 2 observations. Tracing gave you one, finger pinching gave you another. This is the 2 qualities of a mid-segment. This is called a mid-segment. You write that down yourself. So it says right here, if you trace DE and then BC, trace it, we notice that DE is parallel to BC. It's parallel and it's half the length. 2 bunny hops. Now, trace EF, trace EF, trace AB. You should notice it is parallel, those are parallel, and 1 bunny hop, 2 bunny hops, it is also half the length. Now, trace FD and CA, trace. Look at the little finger there. You should notice that FD is parallel to CA and also half. FD is half the length. So the mid segment is both parallel to the third side and half the length. Now we've done this physically. Now we're going to show it mathematically. So right here, we're going to do a quick sketch of where we're going here. In this triangle, STR, we have the points R, which is -4, 8, S, 4, 4, and T, which is at 0, -4. We're going to show mathematically. Mathematically is using numbers because math has meaning. That a mid-segment created by the midpoints of RS and ST, that the mid-segment created here is both parallel to the third side and half. So for now, just eyeball it so you know where we're going. So come here to RS, okay, and kind of eyeball what looks like the middle, and that's going to be the midpoints of RS. So there's a midpoint. ST, kind of just eyeball it there. There's a midpoint. So we connect. We're just sketching. And we're going to prove mathematically that this mid-segment is both parallel and half the length. We're going to do all of this with math because math has meaning. There's 3 parts to this. 1, we first have to prove it's a mid-segment using midpoint. 2, we have to show they are parallel using slope. 3, we have to show the distance is half the length of the third side using distance. So we're using all 3 equations, midpoint, slope, distance, to describe that this midsegment is parallel to this side and half. You can't just say because it looks like a midsegment, therefore it is one. And it looks parallel, therefore it is one. And it looks like it's half the distance because it is one, because. Only parents get to do because. Nobody else. Parents tell you what to do, you ask why, and they say, because I said so. I'm the parent. Totally legit for parents. Even the Bible says so. Obey your parents. For the rest of us, we have to justify every single step. So I, as a math teacher, am going to walk you through that. Ready? Step 1, we have to prove that we have midpoints, first off. So our first ambition is to find the midpoint of RS using the midpoint equation. So this is -4, 8. This is 4, 4. Let's make your template. Add, divide by 2. We're proving mathematically what that midpoint is. Add the x's. Divide by 2. Add the y's. Divide by 2. That's -4 plus 4. That's 0 over 2. That's going to get us 0. And that's 12 divided by 2. That gets us 6. So we have just proven that the actual midpoint is 0, 6. 0, 6, which is right there. That's point D, and it is 0, 6. And we showed it mathematically that that midpoint has the meaning, the midpoint equation has the meaning of middle. Got it? All right. So we just found, we proved mathematically that 0, 6 point D is a midpoint there. Now we're going to find the midpoint going this way, ST. Make your template. Add the x's. Divide by 2. Add the y's. Divide by 2. 4 plus 0 is 4 divided by 2. That's going to be 2. 4 plus -4 is 0. 0 over 2 is 0. So this is midpoint E. We just proved mathematically that the midpoint of ST is E, and it is at 2, 0. But Miss Way, I can eyeball it. No. If I ask you to prove mathematically, you must show math to show the meaning of midpoints. So now you connect from here to here, and now you have proven mathematically that DE, the segment, is a mid-segment. Just proved it's a mid-segment. Now we have to prove the two qualities, that it's parallel and that it's half of the third side. So now we're going to show that this is parallel to that mathematically. You can't just say, they look parallel. I can bunny hump it. Mathematically, I need to see the mathematical computations. So, to do that, we're going to use the slope equation. So R is sitting at 4, 8, and ST T is sitting at 0.4. D is at 0.6. And E is at 2.0. So now we're going to find and prove that they are parallel to each other using the slope equation. So we have to find the slope of RT, and we have to find the slope of DE. We're going to do that using the slope equation. So you're going to make your template. RT, y minus y over x minus x. DE, y minus y over x minus x. Got the negative. There's a negative 4 there. That's important. And R is sitting at -4 as well. So I dropped my negatives. Got to be careful with that. Ready? So that's 8 minus -4. I knew there was something off. And then this is going to be -4 minus 0. Okay, now we're good. So 8 minus -4, that gets us 12. And -4 minus 0 gets us -4, which means our slope for this segment is going to be -3/1. Here, 6 minus 0 is 6. This is -2, which is also -3/1. So we just have proven that this is -3/1 slope. This is -3/1 slope, which proves they are parallel to each other. Why? Because they have the same tilt. The meaning of equal slopes, the math of equal slopes, gives us the meaning of parallel lines. So now we have proven not only is it a midsegment, but they're parallel. And last one, we're going to prove that this is 1 bunny hop and 2 bunny hops mathematically. And we use the distance equation for that. We're going to be doing the distance equation here. Let's make sure I get my coordinates correct this time. R is sitting at -4, +8. T is at 0, -4. D is at 0, +6. And E is at +2, 0. So we're going to find the distance, R to T, and we're going to find the distance, D to E. Make a template to make it easy. There's your templates. Ready? R to D. This is going to be -4 minus 0. It's 8 minus -4. D to E, 0 and 2, and then 6 and 0. Zoom in and do the math here. Go sideways. This ends up being that's 16, 144. So 16 and 144 in the margin. and we get the square root of 160. Now, it's kind of see how the comparative distance is here. If you just leave it 160, so we're going to need to factor this out. So in the margin, square root of 160, just keep factoring it down. We take out our dates. We have one pair of 2's and another pair of 2's. So we have here on the outside 2 times 2, which is 10, 4. 2 times 2 is 4, and then root 10 on the inside. So this length here is going to be 4 root 10. Now let's try this one. This ends up being negative 2 squared plus 36. So that's 4 plus 36. That's square root of 40. And you're like, that doesn't look like it's double, so that's why we are going to factor it in the margin. One pair of 2 comes out, 2. 2 and 5 stays in, 10. Look very carefully. You have now proven that 4 root 10 is twice the length of 2 root 10. So you have proven mathematically that this midsegment at 2 root 10 is exactly half of the third side, which is 4 root 10. We have proven mathematically all 3 things. So back to our original, what we did here. We proved mathematically. First, we found the midpoints using the midpoint equation, so we proved it was a midpoint. That was the first thing. We proved that this was a mid-segment using the midpoint equation. Then we proved that the slopes were equal, which showed that they were parallel. And then we found this distance was 4 root 10. This distance was 2 root 10. Therefore, this is half of that. Our math has meaning.